Okay, welcome back. And today we are going to talk about the next section of probability, and this video is going to be about the general and simplified rules of probability when we're dealing with connectives like and or. And so all of the examples, and this is going to be now putting things together where we're going to use the definition of probability, we're going to use conditional probability, but what we're going to do is we're now going to deal with a little bit more complicated examples, but if you realize that it can just be broken down into smaller chunks, and then you're just basically going to be adding or subtracting or multiplying those pieces together to get your final answer, then it'll be very straightforward. And so it's also going to play on what we talked about before about mutually exclusive events and independent events. Okay, so I'm going to introduce the rules one at a time, or in pairs, and then I'm going to do an example of each one, or a couple of examples for each one, and that's pretty much all we're going to do today. Okay, and that's all that's included in this one. Then as we go on, we'll start talking about using tree diagrams, Venn diagrams, contingency tables to get you those answers. Okay, so there's lots of different ways of doing it depending on how the problem is worded and given to you. Okay, so let's start by just introducing the general and simplified addition rule. Okay, so the general rule applies to any situation dealing with this particular connective. And the connective that we're going to start with is going to be the OR connective. So this would be the general addition rule. Okay, so this is dealing with OR statements. Okay, so in this situation, what we're doing is we're all going to be looking at the probability of A or B. Okay, so either A happening or B happening or both. Okay, so this includes the and. Okay, and one way of looking at that is to look at a Venn diagram. Is we're looking at, hey, if we have something that's like this, and so I'm just going to draw the general Venn diagram here. So here's our sample space, and here's A, and here's B, okay? And so in this case, anything that happens in A, then we know that A has occurred. And if any outcome that happens in B, then we know that B has occurred. And then of course, anything that happens in this piece right here, we know both A and B have occurred, okay? And so in this situation here, what we want to do is when we do OR, we're doing the union of both of those sets. So think of the union is we want to know, hey, what's the probability of anything happening, right? That's A or B, which means either A, right, or B. So the union means everything that they have in common, okay? And so in this case here, so we'll have B and so what we want to do is we want to take all of the outcomes for A and B and put them together, and that's the union. Okay, that's what OR means. Okay, so what we're going to do is we're going to count all of the objects in A, and then we're going to count all of the outcomes in B that give me B, and we're going to take those and we're going to pull them together, and we're going to divide by the sample space to give us the probability. So basically we're going to take all of these together and we're going to divide by all of the possible outcomes to give us the probability. But there's one problem here, and I hope you can see it. What happened when we were counting up all the pieces? If we count up all the outcomes that give me A, and I have that number, and I count up all of the pieces in B, and I have that number, well, what happened? Well, I double counted this middle piece here. So in order to make sure I have the right number total, I'm going to subtract off one of those pieces. And so that is actually what gives us the general general addition rule. Okay? So the general addition rule is just this. It's the probability of A, right, plus the probability of B minus the probability of A and B. Okay? So, but I'm just going to write this underneath. Think about just the definition of probability, right? It's the number of outcomes that give me A divided by the total number of outcomes in S, right? Plus, then the probability of B is just the number of outcomes that give me B, right? Over the total number of outcomes in S, right? And then again, because I'm counting all of those outcomes in A and B, well, I double count it. So I'm going to subtract off one of these intersections, right? So I'm going to subtract off one of the number of outcomes that give me both A and B divided by the total number in S. So again, what does that mean? It just reduces to this, right? So I'm counting these two pieces and subtracting off the middle, one of the middles, okay? So this is the general addition rule. Will work for any case that's dealing with OR, okay? Now, there is a simplified addition rule, and that's because we will have more information. So if we know something about the event, something special about the events, then we can simplify this, okay? So what is the general multiplication rule? Or excuse me, the simplified addition rule. Well, the simplified addition rule uses the fact that A and B are mutually exclusive. Okay? So only if, so simplified, if A and B are mutually exclusive, okay? Then the simplified addition rule just becomes this, okay? Well, and this should make clear based on from the last video that we did on mutual exclusivity and independence. What is the probability that both events will happen at the same time if they're mutually exclusive? It's 0. So this piece right here goes away, okay? And this is all you're left. So basically, if two events are mutually exclusive, the probability that either one of those occurs, so OR, is just the sum of their individual probabilities. And so again, if I draw a Venn diagram, I can, again, use the fact that we can draw mutually exclusive events, right? So again, if I take my A and B, and let's say there's no overlap, right? So these are mutually exclusive events. So if I add, right? So if I just add, like I did before, right? If I just add these, and then add these, right? Well, I don't have to worry about subtracting off or double counting anything, right? because they're mutually exclusive. So it should make sense that based on this diagram that if they're mutually exclusive, then this is all I have to do. Okay? And that is it. Okay? So the question you want to ask yourselves whenever you're looking at a problem and it says, hey, what's the probability of this event occurring or this event occurring? Then the first question that you should always ask yourselves, are these mutually exclusive events? Because if they are, you can simplify your work by just adding their individual probabilities. If they're not mutually exclusive or it's not reasonable to believe that, then you're better off using the general rule. Okay? And that's what we're going to do. Okay? So let's do an example. Let's see here. I'm going to do an example here. Okay. So okay, so here we have Klaus is trying to choose where to go on vacation. It says Klaus can only afford one vacation. His choices are A, New Zealand, and B, Alaska. The probability that he chooses A to go to New Zealand is 0.6. So the probability of choosing New Zealand is 0.6. And the probability that he chooses B to go to Alaska is 0.35. And the probability that both occur is 0. Why? Because we're told that he can only choose one. Okay? So, he can only choose one because he can only afford one. That's what the situation is. So therefore the probability that he either chooses A or B, right? Because this is 0, so these are mutually exclusive events, right? This implies that they're mutually exclusive. A and B are mutually exclusive. Okay, that should be clear. Okay, so that means if I want the probability of A or B, I'm just going to add up their individual probabilities and I'm done. So in other words, it's just going to be 0.6 plus 0.35. And so the chances of him going to either Alaska or to New Zealand is going to be equal to 0.95. So there's a high probability that he's going to go on vacation to one of those two places. Okay? Okay, so now notice that also here that the probability that he doesn't choose any of those places is equal to 0.05, right? Because he's either going to go to Alaska or to New Zealand with a probability of 0.95, but remember, all the possible outcomes has to add up to 1, so there's a 0.05 probability that he's not going to choose either one of those places. He might choose to go somewhere else, right? Okay. So let's look at this. Let's look at this one. Let's look at this example. So here's an example. It says that Carlos plays college soccer. Okay, so let's say he plays college soccer, and he makes his goal 60% of the time. So whenever he makes a shot on the goal, he makes it 65% of the time. So what does that mean? It means that the probability, right, so we could say in this example here, that at any time that Carlos attempts to make a shot on the goal, he is successful 65% of the time. So the probability of making a goal is 0.65. Yep, 0.65. Okay, so let G equals that he makes the goal. Okay, now let B be the event that he is successful on his second attempt. Okay, so now the probability of B, right? So makes the goal, and then B is he makes his second attempt. So makes a goal on his second attempt. Okay? So now, the probability of B is equal to 0.65. Now, Carlos tends to shoot in streaks. Okay, so that's what we know. He tends to shoot in streaks. The probability that he makes the second goal, given that he made the first goal, is 0.9. Okay, so now they're giving us the conditional probability. So the probability that he makes the first or the second goal, given that he made the first one, is 0.9, 0.90. Okay, so now A, knowing this information, A asks, what is the probability that he makes both goals, right? So the probability that he makes both goals. So he makes the first goal and the second goal. Okay. Well, we can use the conditional probability, right? So if he makes the first goal, what's the probability of making the first goal? That's going to be 0.65, right? So if we use conditional probability like we did before, it's going to be the probability that he makes the first goal, right? That's G, times the probability that he makes the second goal, B, given that he makes the first goal. Well, what's the probability of G? Well, probability of G is 0.65 times the probability of B given G, which is 0.9. And so that probability is going to be what? .618. Okay. Now again, that has nothing to do with what we're talking about mutual exclusivity, but realize that this tells us, well, we already know that they're not mutually exclusive. Why? Because if they were mutually exclusive, this would be 0, right? So again, it should be obvious what we're looking at here. Now, here, part B says, what's the probability of he making the first goal or making the second goal? So that's going to be B or G or B, it doesn't matter the order. So this is going to be the probability of G plus the probability of B. Now, they're not mutually exclusive, so that means we're going to have to add, we're going to have to use the general rule here, because these are not mutually exclusive, right? Not disjoint. So we're going to have to use the general rule, and we're going to subtract off the probability that they both happen. Okay, well, what's the probability of G? Well, we got all the information here. 0.65, right? 0.65 plus 0.65 minus the probability that they both occur, which we calculated in part A, is 0.618. Okay, and so what's that probability? Let's find out. 0.683. Okay, so that's 0.683. So that's the way we're going to use the general rule. So in this case here, we had to use the general addition rule to figure out the probability. Okay, and sometimes you'll have to use one part, you'll have to figure out this part because we know that they're not mutually exclusive. And then we'll have to use this piece in order to calculate the next piece. Okay, so let me stop there. So this is still 3 point. So basically, this is going to be the first part. So the first part is going to be on the addition rule and using mutual exclusivity, mutual exclusive events. So next time when we come back in the next video, I'm going to talk about the general and simplified multiplication rule, and that involves whether or not we know that the events are independent. So next time in the next video, we're going to talk about the second part of this section, and we're going to talk specifically about the general and simplified multiplication rule. So thanks, and I'll see you next time.